In this video we are going to see one new project that I have been working on as a hobby project, that is a URL shortener service. We all know there are plenty of URL shortener service like TinyURL, we have the Bitly, all these are like very prominent and very famous URL shortener service. But the idea of creating this project is to identify the high level design and the low level design from scratch, which supports these following features of customizing links, expiry, hit count, autocast and eviction of the redirects and analytics. So the entire stack, I was going through one particular blog from the Algo Master. I have given the link in the readme section as well. This is the typical architecture of a high level architecture of a tiny URL service. Now in this particular aspect, we all know there is a load balancer. People are hitting to our load balancer. There are the backend service servers are working on, and it will be having a URL generation service, redirection service, database, cache and whatnot. In this particular aspect, now what I have done is basically in this database, preferably everyone mostly it's better to go with a NoSQL DB because it is a high read heavy system, right? So even let's say one link is being created, there would be 100 redirects, so it is a very read heavy system. In that second point, you does not need any ACID compliance over here. You are not going to do any kind of joins, complex queries, so on and so forth. So it's obvious you can go with the NoSQL databases like columnar DB, like Cassandra, Mongo, Firebase, something. Okay, but still I am using Postgres, which is a very famous database. The thing is that there is the entire URL redirection service. I am not using a NoSQL database for this. I am using a SQL Postgres database, which some performance tuning like wall, turning off the wall, that is a write ahead log, or the creating the unlocked tables for whichever the links or whichever data needs to be cached. And there is a caching service for like caching the URL redirection as per the active hit count, depending on the expiry and the hit rate of the click rate on the URLs. That will be automatically cached in the Redis client. Okay, now the thing is that entirely, if you can see, this particular segment comes with various API references like login, sign up. Then we have the shorten service. There are the two shortener service. One is V1 and V2. Okay, I will come to that how it is going to working. But let's jump on the demo. Okay, let's start the project understanding. This is built on top of the tech stack is Golang, and I have kept the entire stack is very minimal and grounded, and chosen only battle tested framework or technologies or anything that you are calling on. Okay, the first is Golang, and here for the web server also I'm not using any blotted anything, because in Go world there are no blotted any frameworks is available, right? There is only the necessary things are there in Go ecosystem. So I'm using net slash inbuilt HTTP server. There are the Postgres as a database, GoSQL from Dr. K's repository, which uses the basically prepare the SQL statement for faster execution, preload or the prepare the SQL statement so that you can run directly with the argument passed, execute rows and everything. Bloom filters, this is a very interesting thing that I have using, because see, right now I am giving a one service to the users, that is a custom alias. Okay, if you want to create a alias for your URL for easy memorization, you can do that. But the thing is that to check whether alias is present or not, we need a probabilistic data structure which will tell you whether that alias is available or not. For that I am using Bloom filters. Okay, and let's see the demo first. Okay, I have given the how to run this particular project also, but before we jump there, let's see this. So this is the typical Go project that you are right now looking at. From this is this command, the slash main.go. In this file there is a init which will initializing the core components or the dependencies to run this particular application on any environment or any server, and there is the HTTP servers that are being booted. Okay, now in this particular segment, if I hover, what it tells is that it helps to initialize the necessary configuration to run the backend services. This handles the heavy workloads of initializing dependency into a single construct, reducing the error prone, and it checks all parameter before work in progress. Okay, let's see the init. So this is the particular init function, the dependency that I am talking about. I am initializing it over here, the port, the JWT secret, okay, the database, the DSN, that is a data source name. Bloom filters I am also initializing over here. We will also see the Bloom filters, how it been used basically. And the Redis client, for Redis I am using in the Docker Compose. So if I open the Docker Compose file over here, let me just open the Docker Compose. So this is the typical, see, I am using a Postgres, I am using Redis, I'm using pgadmin for the database as a DVMS, and this is my prepared service. Before you, when you are working on it, if you don't have the image, then you can easily turn it off and then run the Docker Compose this infrastructure. That will work. Ideally, I have created, so I have added that URL shortener service and provided the necessary environments to connect to run the particular services. Okay. Now after that, I am initializing the database. So this is the database initialization method that you are able to see all the necessary checks we are doing. Then after that, I am preparing the SQL statement that I have told you. So you can find that necessary SQL statement over in this particular directory, in this particular .sql files. So here all the necessary queries that I need, that is needed by the different services, I have here wrote those raw SQLs over here, and database prepares the SQL statement for the quicker execution. Okay. So here you can see I want to have a get user by email, create a new user, create sort URL query, increment the URL hit count. Okay, then I have the get incremental ID query that which I have told you. Basically the Postgres sequence I am using over here. This is the get all sort alias URL. Okay, and this is the most active hit count query based on the parameter. So all these raw SQLs has been already written. To create or to migrate your data and to create your database infrastructure, this is init.sql query. Okay, so here all the necessary table configuration, the required indexes, foreign key references, everything are mentioned over here. As you can see here, I have created an unlocked table, okay, which will generate the incremental ID for the other services that I will talk to in version 2, API 2. Okay, this is the URL hit count table that has been created, and these are the URL mappings. Okay, all the URL mapping over here I have created. Now after that, there is a particular statements that you can see, preload Bloom filters. What it does, preload Bloom filters will preload the Bloom filters with the existing sort URLs. This is done to improve the performance of the custom alias availability handler. Caller must run it in separate Go routine, as the aliases will be huge and it will be across the cluster. So there would be various different aliases that you have to be cached. Okay, for that, if I go here, very simple thing, I am using the get all sort URL query. So if I go again in the URL, get all sort URL. So this is the all URL. So what I am doing, select all the different sort URL from the URL mapping table where expiration date is not expired. Okay, so all those sort URL aliases I am basically taking, and I am just inserting into my Bloom filters. Okay, so what it will do, it will create the Bloom filter, it will preload my Bloom filter. Next, what we have, this is running on a Go routine. Okay, now after that, what do we have is basically cache the sort URL. Again, as you can see, what it does, it helps to cache the sort URL original URL mapping into Redis. This is done to improve the performance of the get original URL handler. This is an entire blocking infinite loop. Caller must run it in a separate Go routine, as the aliases will be huge and distributed. So what it does is basically, if you look at the implementation, this is doing nothing but a blocking an infinite loop, infinity loop. When we run this particular segment on a separate Go routine, so it will not blocking the main thread. So my services will run separately without any issues, right? And I'm just populating my Redis. And how I am populating, I am querying the most active hit count query. Again, if I go to my queries, this is the most active hit count query. If I copy this, okay, and let's say I am running my this thing, like running the entire infrastructure. Okay, let it run. So this is the particular query. So all this query, what it will do, it has started. So if I go here, go to 5080. Okay, it's been run. My DVMS is up right now. I have to create the connection right now. Postgres root Postgres. Now if I paste this query and run, so you will find out what are the URLs that has been cached. And if I just pass the hit count over here, you will get to see this is the overall hit count of my URLs. Okay, and this particular URL, I am having a many different URLs. So what is the total count of the URLs I am having from your URL mapping? There are 20 different URL. From that 20, I am only caching 3. So 20 is to 3. So similarly, if you look at the scale, it will be very huge. So which is why I am basically caching the only necessary URLs. Okay, so this is the first case. If I close it and also stop my infrastructure because I don't need it right now. So what do we have? This will work. Okay, now let's look at the server, because after the main function I am initializing a new server and I am running it. So what are the different things? This is the typical Go construct. This is the typical Go net/http server, how you are going to define your endpoint. Okay, there are no additional third-party libraries or anything I am using right now. I'm going with the standard HTTP server which is available in the Go. That is a Mux HTTP, right? Go Mux server. Now here I am initializing everything, and after that you can see here I am also created some custom middleware. I have the log middleware, rate limiter middleware, and custom require context middleware. Let's see the custom require context. This is the entire context. See, right now I have told you that I am using a core. Okay, that is my configuration. How I am getting from the server? There is a core component. Okay, that core I am initializing in this CO. I am passing it to my core, and then I am initializing my server with that, and also I am initializing the custom context. Okay, now once that is my context is ready, later I am having, what do we have right now? After the custom context I have the rate limiter. So this is very important, right? Because rate limiter will be throttle the IPs or the client which are bursting the traffic into the API server. It puts the detected IPs into a minute pullback. So what it does is basically in the rate limiter section, this is the custom rate limiter that I have implemented in the from scratch. Okay, how it has been implemented is that there is a rate limiter client. There's the three parameters I am using: the limiter, the remote address I need to detect, and the last scene. Okay, after that this is a sync mutex that is doing the permissive blocking. Then clients I'm storing into the clients. Then we have the custom go routine over here, which is again an infinite loop. See, this is again infinite loop, and this is a running onto a go routine which will not block the main thread. So I'm just iterating to it, doing the whatever it is. If the last scene is more than the 3 minutes, I am deleting the client because I do not need to block that client or throttle that client, right? Then this is the particular middleware that has been created, all similar go construct after that, and I am just adding a accelerate limiter and the current timestamp, okay, when that particular request has appeared on the server. And later what do we have as a logger middleware over here, which will just log each and every request that are being received on the server for the audit trails and the service logs. Okay, then this is the typical endpoints. Post endpoint, we have the sign up endpoint. Then I have the API slash v1 sorted URL. Then I have v2, and there are the sorted URLs of sorted URLs and check aliases. Okay, let's look at the, see, right now v1 and v2 is very similar. It will not create any problem, but still look at the implementation. v1 get sorted URL, it is just doing the sanitization over here. I have basically created the DTO for it. Original URL, custom URL, expiry, you can pass it, and sanitizing the URL and the expiry. Here it is generating the hashing. Okay, then it is converting that hexadecimal hash to a decimal integer. This is doing the conversion of bytes to decimal. Okay, from hexadecimal to decimal, and once it is converted to decimal, it is doing the encoding, base 62 encoding. And once it is done all these things, it is going to save it to the database as a transaction. So meanwhile there are certain transactions that will be executed on the database side. If any of the transaction failed, it will not get created, it will be rolled back. So here is the transaction implementation. This is the pure without any ORM, the Go construct of writing the transaction on Go. This is the 3-4 different statements. One statement will insert the sort URL to the URL mapping. Another, it will check the ID of the sort URL if it is present or not, and returns the ID. Once it is returning the ID, it will be creating the foreign key references on the URL users and URL mapping table, and also it will add that particular sort URL to the Bloom filter. Okay, so that aliases will be automatically entered into the Bloom filter, so that no one can create a similar aliases until that URL is expired. Okay, later on let's look at the Postman right now. So there is particular login endpoint, sign up endpoint, and v1. Okay, if I hit it, okay, I have to start the the infrastructure right now. Let it start, and what do we have is basically the v2 endpoint. In this v2 endpoint, look at this particular endpoint. These are specific endpoints which needs the auth middleware. So the auth middleware are for a specific URLs which does the claim and verify the token. It just adjusts the user ID and user email, whichever is required, and verify the JWT token passed by the user, checks in the database whether that user is valid user or not, is everything is proper, authorization is proper, RBAC is proper, everything. And it basically sets the context, request context with the user ID and the found URL. If each and every all these top level checks are being fine. Okay, this is again a Go construct and implemented from scratch. No additional bloatware has been used, so everything is from scratch only. See, right now my this thing, the all the services, the PG admin, Postgres as a DB, Redis as a client, caching, the URL shortener service are also that. Now here is this some interesting facts. See, this is the DSN and the Redis client from ENB. Okay. After that, see here are some this thing. What do we call it? Bloom filters which are being ran. Okay, it is not blocking anything. See, my PG admin is also running, Redis is also running, caching servers are also like caching is also being done. So all these are running on a separate go routine, so it will not create any problem blocking this thing. So what is happening is that once as soon as the server is up, all your DB connections and all the checks are done, then it preloads the sort URL aliases based on the query to the Bloom filters, and as per this log, these are the aliases which are being active and being used. Okay, now what is happening, it is just caching all this not caching, it is just adding all these aliases to the Bloom filters. Okay, once it is being added, after the Bloom filters are filled, in the separate go routine, the addition of the sort URL to the cache. So if I run, as I have shown, that particular 3 URLs are very active URL. So as it is active URL, you do not need to do any DB call, right? Because DB call will add 100 millisecond latency to the service. So to that, do that, to maintain that, I am just adding the query like caching Facebook, Google, and the GitHub link that I have added. Authentication server mode has been up, and here also you can see after each 1 minute, or the cache invalidation is 1 minute right now. So after each and every minute, the for loop will run, that infinite loop will execute, and it will preload. See, like till the time I was talking, the URL shortener service, the adding to cache, invalidation, and everything is working separately. It is not blocking anything, right? So ideally, we have these 3 URLs in the cache. We have the Facebook URL, Google URL, and the GitHub URL. All 3 are in cache. Okay, so I have to basically hit again. So as you can see, token is invalid. I have to regenerate the authentication token. I am using the login endpoint. Just copy pasting the access key to the URL authorization. I come here, paste, save, hit again. This is a duplicate key. Okay, the key is already present and it is active, right? So what I have to do is LinkedIn this thing. If I just turn off the this thing, no, and let's say I'm adding Instagram, and expiry date I want to set, or even I do not want to set. Say for example, I'm just removing this two parameter from here, and if I hit it right now, original URL is, so this is the shorten URL that has been created. So right now this URL specifically, okay, is not cached, right? It is not cached. So if I copy this URL and go to browser and try to paste it, what it will happen, it is taking some time, and then going to the Instagram, and from the logs you can see here, the logs, what it says, it is a cache miss, right? It is a DB call. But as soon as I type over here same URL, Google, so here you can see it is a cache hit. It is a cache hit. Okay, so ideally it is not going to any URL or anything. Again Google, quickly it loads. If I come here, type google.com, no DB call. It's like it is just going to Google like a very speed, right, in a speedy fashion. So it is all cache hits right now. So see, all these are cache hits, but right now that particular URL is not this thing is not cached right now. If I hit it, it is taking time, and then it is going to particular URL right now. Again you can see it is a cache miss, but I can also do a caching of this URL. If I come here and I forcefully run some scripts to cache this URL, say for example I'm just coming here and pasting this URL, hit enter, hit enter, hit enter. See, there is a rate limit is also getting hit. So the thing is that somehow the URL will be cached, okay, but still it is not blocked by the API server, because I am trying to brush out the traffic for this particular URL, and this is hitting the caching servers right now. It is not allowing anything. Now if I try again, let's see if it is cached or not. See, right now it is cached. Why I am saying, because if I come here, it is again a cache miss. Okay, so I have to check the DB, what is the status. How can I check it? Go to 8080 browser, it is a.a and password. I have to create this PG connection, Postgres, root, save, PG Postgres query. I have to check the queries here and select the hit count, so I can get to see, okay, see, it is right now cached and 29 times it has hit. So accordingly, if I go here and tries to copy this, cancel, go, paste, this is a cache hit right now. So ideally I can see, just give me, stop this, leave, localhost 3000, this, let's see now. It is a cache hit right now, so it is serving from the cache, right? Again I am trying just for the demonstration only. Is trying to open. Okay, so this is the particular thing is being run. This is right now all cache hits right now. How it is working is that it is coming to the Bloom filters. If you look at the authentication service, authentication is standard only. I do not need to talk about much on that. But this get URL shortener service, in this get URL shortener service, what it does, it is incremental the hitting count. Okay, get shortener service, it increments the count. Once it increments the count, it tries to look at the cache. If the URL is present on the cache or not, then it prints a cache hit, otherwise it's a cache miss. Okay, and then what it does, it's basically get sort URL by query. If it is a cache miss, it is going to check from the database and run it. And this is the custom alias check. I'll show you the custom alias. LinkedIn, I have already used it, right? If I hit it, the alias is already taken. So in the logs also, if you can see here, checking the custom aliases in the Bloom filters, and as long as I told you, this particular authentication endpoint is auth middleware, every time I'm checking, it is just verifying the authorization for me. Okay, remote IP from which IP I'm just calling it, and if I am authorized or not. So all these checks are doing are running on the backend and checks the LinkedIn if it is valid or not. If I just add a n over here, this is available. So user can create his own custom URL using this custom alias. And if I create the same URL with double n, if I go to VT and here, see, if I hit again now, it will give me a different URL over here. But if I add it and the same linkedin.com, if I hit it now, LinkedIn is created. So if I just copy paste, come to browser, hit it, what will happen? It is doing the DB check and it is opening my LinkedIn account right now, right? It is a cache miss. Okay, it is a cache miss right now. Similarly, you can also run the same thing, rate limiting link. If I just hit it for a couple of times, even though I am getting rate limited, but who cares right now? All these are rate limited, like all these are hitting the rate limits right now. But still, let's see how long it will take, if it is getting cached or not. Let's see. Right now it is a cache hit right now. Oh, again, so I have to try some more time. Let's try it now. Still it is cache miss. Interesting. Cache miss. Let me try again. Because I'm hitting the rate limit, right? But I'm trying to forcefully register this LinkedIn to the cache. Let's try it now. Now I got it. Now it's a cache hit right now. So if I go and hit again, so it is not doing any DB call right now. See, it's comparatively faster than the DB call. I am on incognito, that is a different case, but the thing is that right now it's cached, so it is not performing any DB calls right now. It is all a cache hits right now perform. If I just come and type Google is directly, it is getting opened. If I type enter, Google is directly open. So these are all cache hits. So that's all. Specifically, it's being working, and it is basically powered by the Bloom filters only. So Bloom filters is doing the magic for the alias checks. Okay, and these are the particular version endpoints: DTOs, handlers, services, auths, handlers, write endpoint for writing the JSON and all. Servers that I haven't already discussed, and most of this is the case, and this is the Docker file for that. Very standard Docker file for doing the containerization of the any Go services. And that's all. This is a make file, read SQL queries, everything is proper, and I hope you have enjoyed. Okay, there is also a health endpoint. If I go, oh sorry, so, see right now this is the particular URL, no URL found, because if you do, if this hot URL is expired or that URL is not registered now, it will give you an 404 error that the URL is not available. But if I do a health check of this endpoint, API is healthy, and from which hostname it is being traveled, this is the container hostname right now, and the version is 0.0.1. Okay, so that's all. I hope you have liked it. If you like that particular demo, this is the particular GitHub repository, sonisnath/URL shortener service Golang, and it basically has the entire blog which will be written. If you like it, then you can connect me on LinkedIn as well if you want to extend the connection of the connection. And other than that, if you also want to look at it, this is my particular portfolio. where you can reach out maybe. And I hope that a particular feature will be available, and I will write a blog for this particular segment, which will basically I will create a blog for that also, how to create a tiny URL service. And that's it only. Yes, so here you will see creating of the tiny URL service on Golang. It will be available over here. That's all. Thanks for watching. Thank you.